Welcome to Easy Academic. In this episode in the linear algebra series, we'll be discussing linear independence of vectors. So what does it mean for a vector or a set of vectors to be linearly independent? Let's say we have a vector A, B, and C. When we want to say that this set of vectors, so we denote a set using these brackets, if we want to say that this set of vectors is linearly independent, that means none of these vectors, being A, B, or C, can be created through any linear combination of any of the other vectors. And so for more information about linear combinations, refer to the video on the card. But formally, if we want to describe that it's impossible to describe any vector in a set with a linear combination of other vectors, how do we do this? In order to formally describe linear independence, we can have an arbitrary constant lambda I. And lambda I can take on any value of any number, which we'll use to multiply by A, B, and C. So let's say lambda 1 times A plus lambda 2 times B plus lambda 3 times C is a linear combination. If we want to figure out whether or not A, B, C, the set, is linearly independent, we check whether or not this linear combination equals 0 if and only if lambda 1, lambda 2, and lambda 3 equals 0. So what does this mean? This means that the only way to combine A, B, and C together to go back to the origin is if we multiply all of them by 0. And so geometrically, how do we interpret this? Let's say in 3 dimensions, we have this. Let's say this is vector A. It's the unit vector along the x-axis. Let's say vector B is the unit vector along the y-axis. In green, we'll say vector 3 is the unit vector along the z-axis. So we have these 3 vectors, A, B, and C, which we can denote A, B, and C, and say we want to describe A in terms of B and C. So we can say that lambda 1 times A is equal to a linear combination lambda 2 times B plus lambda 3 times C. By inspection, the only way that it's the case that we can describe the A vector using B and C is when B and C are both 0 and when A is 0. So say we've multiplied A by 0 and this vector equals 0, B and C must also be 0. Otherwise, it's impossible to describe something on the x-axis using only components in the y and z-axis. So just to recap, broadly speaking, let's say we have an arbitrary number of vectors, which will number v1, v2, all the way through to vn, and these are just all of our vectors, n vectors. And so we want to see whether or not these vectors are linearly independent. In order to check that they're linearly independent, we have to check for ways that we can add them to equal 0. So say these are n-dimensional vectors. All of the entries must be 0 when we add them together in a linear combination. And the only way for that to happen in a linearly independent set of vectors is when we multiply v1 times 0 plus v2 times 0 all the way to vn, which will also be multiplied by 0. Be sure to like and subscribe, and if you have any questions, feel free to leave them in the comment section below.